Yeah. So can you see my desktop now?
Yes, sir.
Okay. All right. So for the sake of the people who do not have laptops yet, for example, Isaac doesn't have a laptop yet, so he doesn't have a way of installing Python and all that. And so I thought it would be better I teach you guys using Colab until everyone has a laptop of their own, and then we can go back to writing our script in files. So henceforth, I'm going to use Colabs until further notice.
Okay.
And
What's that again?
Colabs, Google Colabs, I've seen you use it already. It's like Jupyter Notebooks, just that
Okay.
Colabs is a free Jupyter Notebook hosted by Google for you. And if you're doing serious stuff, they give you access to GPUs and TPUs to help you like accelerate your computations. So to access that, you just go to colab.research.google.com. That is how you access Google Colabs. And so when you come here, all the files you've created will stay in your Google account. So these are all notebooks that I have created in my previous tutorials that I've recorded onto YouTube. And the way to create a new notebook is just to click on this new notebook thing. And it will take a while for the UI to load. Once it loads, this is basically very similar to the Jupyter notebooks that you have installed on your local computer.
Okay.
So the first thing you want to do is to give your notebook a name so that it's easily identifiable. And to do that, you just click in the Untitled. So if it's your first notebook, then it's going to be Untitled 1. But I have many notebooks, so I'm going to name this as Booleans in Python. And
one second, sir. Do I have to use it, or it's okay using the Jupyter?
no, it's fine. It's fine. If you already have Jupyter installed on your computer, it's fine. Just that the advantage of using this Google Colabs is available in the cloud. So if you leave your computer behind and go somewhere, you are always able to open what you've already created and continue working from there. So it depends on which one you like most. But the features are almost the same, except one has some advantage. For example, if you come to runtime, you can change the runtime type. And so over here, you are free to choose whether you are using a GPU or you are using a TPU. And if you are doing serious deep learning stuff, which we will get into, then you want to take advantage of this free GPU or TPU to accelerate your computation so that things will be faster. So this is one added advantage aside having it in the cloud. Okay. All right. So someone who is not part of us watched the YouTube video and sent me a correction. And myself, I was very surprised about myself when we couldn't get the first formatting style to work. And the reason was
the percentage one.
Specify. Yeah, I forgot to specify. So each placeholder has a type that you need to specify that indicates what is going to be used to substitute for it. For example, let me just clear this and then we start working on Booleans. So for example, we had this example where I said F name equal to Edward. Is the font size big enough?
It's a bit tiny.
Okay, let me increase that. Is it okay now?
Yeah, this will do.
Okay, all right. And then I said L name is equal to pi. And what we wanted to do was to concatenate them or use that formatting style to, create a new string out of these variables that we have already declared. So what we were supposed to do, let's say I want to get something like, I want the result to be something like this, pi Edward, okay? So I want the full name to be written this way. What we have to do with that style, which we couldn't get to work, is you declare a variable and you say percentage. You see, this is the mistake we did the other time. I said percentage, and then I came here to specify what is supposed to be substituted in place, like F name and L name. This is not going to work. And so this is the exact same error that we were getting the other type error, not all argument converted during string formatting, blah, blah, blah. So what we are actually supposed to do is you specify a type for each of them, okay? And then now we can print, if we print full name, you can see that it gets printed. So the problem was that we were just specifying the percentages without the type. So percentage S means you are going to substitute a string in its place. And if you're going to put a number, you can use percentage D. If it is a floating point number, percentage F. I mean, these are not things you need to memorize because you not use them as much as I want you to be using F strings, because that is more modern and a lot more nicer than these ones. So this is just to correct what we couldn't achieve in the last session. Okay. All right. So now let's get to what we are supposed to talk about today. Has any other people joined?
You joined Stephanie. You joined Stephanie, and I also joined the guy.
Yeah, but I mean, to this call, I'm not seeing that they are here yet.
It looks like it's just the two of us.
Okay, all right, no problem.
Is Mrs. Kai around, please?
No, she's going to get some stuff. I mean, they can always watch this recorded session. So,
right.
All right. So we were talking about Booleans the other time, but we didn't talk about it in depth. And I explained to you that Booleans are very simple data types. They can store just two values, unlike integers and float and strings that can store almost infinite number of different values. When you declare a variable and it's a Boolean, then it can only take on two states. It's either true or false. And what we are able to do with these type of variables is called conditional statement. They help us to create conditional statements in our program. So I also shared with you that conventionally, and whenever I say conventionally, what I mean is that whatever follows that word conventionally is not strictly by force for you to adhere to, but within the Python community, things are expected to be that way. Okay, so when I say conventionally, if you declare a variable, try to begin the variable name with is or has, depending on whichever one reads better. Okay, it helps code readability. For example, if I want to store that someone is underage, you see that it reads well when I say is underage. Is equal to, let's say, false. Okay, so this here has resulted in we creating a variable called is underage and then storing the value false into it. And like always, we can check the type of is underage. So if we check the type of is underage, we expect to have a bool because that is a Boolean. We can also have another variable, let's say has completed, is equal to, let's say, true. And then let's print out has completed. Or let's just check the type of has completed. So I'm going to print the type of has completed. Has completed. And we also expect that it is going to be a Boolean. Now, Edward, tell me, when do you think is good to start your Boolean name with has?
Depends on the statement you're trying to put out.
Yeah, so think of one scenario where it's okay to use has as compared to is. I mean, let me give you an example. This has completed. It could be that I'm running a long running process and I want to know if the long running process has completed before I go on to do something else. And so I said conventionally because it is not compulsory. I mean, you can name it any way you want, but it doesn't help code readability. In as much as Python is a very simple and expressive language. It is also possible to write very, very terrible bad code in Python,
Yeah.
which heavily affects readability. And so some of these things, aside we learning how to program in Python, I want us to also learn how to write clean code, because it's not just about writing code. It's about writing code that is clean enough so that it's easily maintainable. The truth is, if you write code and you don't write it well, it will surprise you that after 2 weeks, you look at your own code and you realize you don't understand it as much as you did when you were writing it. It is very, very possible, especially when you are caught in the heat of the moment, where you are only concerned about getting something to work, and you don't pay so much attention to how you name your variables and even how you structure your code. So I want us to merge these two skills and learn them at the same time. So aside learning how to program in Python, we also want to learn how to write clean code in Python. Okay.
All right.
All right. So now we know how to declare variables of the type Boolean. Any questions so far? Feel free to stop me if you have any question.
Oh, okay. Can you give two statements and ask? So I decide which one should start and which one has.
Okay. So
or two conditions, yeah.
Yeah. So you are building a payment processor system, and you're using Python to do that. Now, in the first scenario, you want to check if the person's login detail is correct, and therefore you have authenticated the person successfully. How will you name such a variable?
Has.
Why has?
Because it's met a condition.
Yeah, but in this case, there is no, I mean, I don't want you to think of it as something that is set in stone. In this case, you can say has authenticated is correct. You can also say
Yes.
is authenticated is correct.
Yeah.
So you just think about it within the context.
The one that sounds good in English, or?
Yeah, yeah. So you just choose the one that sounds right in English.
Like
And
proper,
for this
it sounds like
scenario,
grammatically right.
I think in this scenario, both of them sound right. Has authenticated and is authenticated. You can say if the user is authenticated or if the user has authenticated, but I think is more appropriate here.
Okay.
Yeah.
Okay.
So any other question?
That's
Okay.
That's it for now.
All right. So I'm going to explain something else. So you know that Booleans can take true or false. But in Python, every value has what is known as a truthy. And what I mean is that you can store any other value into a Boolean, and depending on the content of that value, the Boolean will result in being true or false. For example, if I say print, let's, what is this? Why can't I? Yeah. So let's say I'm declaring a Boolean. I'm just going to call it B. And I will say is equal to 10. Okay. And then I will check, is B equal to true? So let's do print B equals true. I'm going to explain to you why I use two, why I'm using two equal signs here. Okay.
All right.
If I do if B equals true, whenever you use two double equal signs, it is called so you are basically checking. One equal sign is for assignment, and then two equal signs, you call that equality check. So you want to check if what is on the left is equal to what is on the right. Okay. Now over here, I said B is equal to 10, and I said print B equals true, and it's returning false. But let's see the twist here. If I use this in a conditional statement, and so I'm being a step ahead of myself here, because the next logical thing to talk about is conditionals, but I'm bringing it in here and then we will backtrack. So I can write a statement like if B, then print welcome. Now, this if statement here, the way if statements work in Python is you write a if and then you bring a condition, okay? The essence of the condition is to evaluate to either true or false. And if the condition evaluates to true, then whatever follows in that if statement is going to be executed. Otherwise, it will skip it, or if you added an else block, the else block will execute. Otherwise, if you have an if else block, then the conditions for each of these blocks are going to be checked, and whichever one matches will have it following or subsequent statement executed. Now, the twist I want you to get here is this. Over here, I said print B equals true, and it said false. So if B is equal to false, how come it is printing welcome? What do you think of it?
1 second, please.
Yeah.
B is equal to 10, print B equal to print welcome.
Okay, let me help you here. Now, when you use the equality operator, what is actually happening? You see, this is what it means when you are learning a programming language. It's not just about seeing how to construct statements. It's about really understanding what goes on behind the scenes.
One second, boss. Please, you've been made the host, so just in case the other colleagues are trying to.
Okay, I'm not seeing anybody trying to, but anyway.
Also, I've logged out. My phone is on airplane mode now.
Okay, all right, that's fine. Okay. So why do you think, I was explaining that it is not just about knowing how to use it, but then knowing what goes on behind the scenes. So if I say if B is equals true, it is actually checking if B contains true. Like in this line here, this print B equals true is actually checking if B contains the value true. Yes, but in this case, it is not containing the value true, okay? However, on this next cell, and by the way, each of the sections in the notebook where we are able to type is referred to as a cell, yeah. And there are two different types of cells. You can have a code cell or a test cell. So the whole idea is you use the test cell to write your notes, and then you use the code cell to. So if there are any notes you want to add to any of these sessions, you can click and add a test there, and you can use Markdown or latest to write your notes over there. And I think we'll get there. So in this next cell, what is actually happening is the if statement is checking the truthy of B, not necessarily if it contains the value true. Of course, if it contains the value true, then it is true. Otherwise, in Python, anything like any value has something that helps it to evaluate the truthy nature of itself. And so let me show you something. If I put 0 here and then I check, is B you print B is equals to true, it said false. Now let's come here. You see that this time around the welcome is not printed. So automatically what you learn is that in Python, if an integer is 0, then it evaluates to false if you use it in a conditional statement. Okay? Yeah. Otherwise, it evaluates to true. Let's check a negative number. Let's say negative 100. So yes, the print statement as expected, it remains the same. Let's come to this. Do you see what is surprising here? So
it has been printed.
Yes, it has been printed. So what you learn from this is that 0 is what evaluates to false. Anything else evaluates to true.
I thought it was just 1.
You thought it was just 1, as in the number 1?
Yeah.
No. So in a language like C, then that holds. In C, an integer 1 is true and 0 is false. But Python has its own way of doing things. And that is what I always stress on, that when you are learning a language, you are really learning the inner workings, like the details of how things work, the semantics. Yeah. So, and this is one thing that I like about Python, the fact that you can have an interactive shell and then you can try all these things. I mean, there are some of the things I do that I don't know it off head. You can always try it and then you see, and then you say, okay, this is how it works. But with experience, you begin to be able to spot some of these things by just looking at them. So you know that if you store even a negative number, the fact that it's negative doesn't make it false in Python. So what we are certain to make it false is 0, because if we set it to 0, then it is evaluating itself to 0. There are other data types in Python, which we will also talk about, hopefully today. But I'm also going to go a step ahead of myself, and then I'll use one of them. There's a data type called a list, which helps you to store multiple items in one variable. Now, if I open a square bracket and I close it, that is a list in Python. Let's see what an empty list evaluates to. So an empty list evaluates to false. Let's put something in there. Let's say I have a list that has the number 90 in it. And now you see that if the list is not empty, then we get it to evaluate to true. You get it? Okay. So let's go back to 0.
An empty list is always false.
Pardon?
An empty list is always false.
Yes, an empty list is false. And if there is something in the list, then it evaluates to true. Okay. Now let's talk about the simplest form of conditionals, because we needed to complete what we started, the ATM simulation we started last week. And then we talk about different other data types that are available in Python. Okay, so why do we need conditionals? You know that when your code is executing, it executes sequentially. Sequentially means the first line of code will execute, and then the ones that follow and the others that follow. Now, real world programs are not this simple. It is not just a set of 100 lines of code that must always be executed in the same order. In the real world, there are different scenarios that are different ways of doing things. And so whenever you set out to build any non-trivial program, just knowing how to create simple statements is not enough. You need to also know about how to write conditional statements. And that is why every programming language has a way of letting you express a condition, okay? Now, this is the form of a conditional statement. You first of all bring the if statement. I mean, this would be better if I use a test cell. So I'm going to insert a test cell here. And so I'm going to use Markdown. So we are talking about conditional statements. Conditional statements. And we are starting with the if statement. Okay. Now the structure of an if statement is you start with if, and then you write your condition, and then you bring the colon, you hit enter, and this is very important. You need to leave at least 4 spaces.
Okay.
And then your statement. So I'll say statement 1, statement 2, all the way to the other statement that you want to execute. Now I will explain something here. I didn't get this guy to format itself the way I wanted. I think it wants to go. So for Markdown, if I want the down, I think that is what needs to be done. Leave 2 to this. Now let's run this. Okay, now, no. I'm not getting this to be the way I want it. So if condition, let's see what happens with this one. Markdown. So let's bring this down. Okay, I mean, we'll keep it the way it is. It's fine. So basically, how you use an if statement is you bring the if, and so any token, and by token I mean anything you write in your code that is expected to be the way it is known as a keyword. For example, the if is a keyword. In each place, you can't substitute anything else. It is meant to be written that way. It has to be an if statement. If you want to write an if statement, it has to be an if. Unlike the variables that you declare on your own, which you are free to come up with any names that make sense for you as far as your program is concerned. When it comes to keywords, you don't have a choice as to how to spell them out. If you misspell it, then it's a problem for the interpreter, and so it's not going to work. So if is one of the keywords in Python. Okay. All right. So the way
So
to
can I say the keywords are the ones that are inbuilt in the system already?
not every inbuilt thing is a keyword. For example, this print here, I mean, it's not technically a keyword, it's an inbuilt function that ships with Python. Of course, you can't also misspell it, but you can't really call it a keyword. Otherwise, then every function that ships with Python, you have to call it a keyword. Yeah. So
basically,
keywords are actually not functions. They help you to create your statement.
Irreplaceable.
Yes. I mean, even for the function name, they are also irreplaceable, but that doesn't necessarily make them keywords. So, like the function is not necessarily part of the tokens that form the language. You see, the way they create a programming language is they create the barest minimum that is needed to write the simple programs, and they leverage those barest minimum tokens to come up with high-level ones. So this print statement, it could be that it was even implemented in C and they are calling it in Python, or they could reuse what has already been made possible with the existing vocabulary. So let me use vocabulary here. You see, if you look at what defines the Python language, it has an intrinsic set of vocabulary, and those ones form the keywords. Okay, because this print statement it can be implemented in Python or it can be implemented in C, but they are making it available. And one way, you can just Google, let's say Python 3 keywords, and you can see a lot of them here. So you see, and continue, for, from, blah blah blah. You can check all these guys out. But I don't want you to mistakenly think that every inbuilt function becomes a keyword. As you can see, there's no print here. You get it? Yeah. So that is it. All right. So the way to write your statement, your conditional statement, is you begin with the if, and then you bring the condition that should be matched. Now, what is inside the block? And by the block, I mean, I need to stress on this. Python is very particular when it comes to indentation. In a language like C++, you could do something like if, let's say, age is equal to 18, then you open and close curly braces like this. Now, everything between these curly braces is considered to be in the same block. So the block is delimited by the opening and closing curly brace. So in C, I could also do else. So I'm going to use this C statement. We cannot use it here. Like, we cannot run it in this notebook because this notebook is sitting on a Python backend, but I'm using it for explanation's sake. So the way if statement work is, if it will check this condition. The condition here is, read it this way: is age equal to 18? If age is equal to 18, then every statement that is included in this first block, the first block is delimited by the first matching opening and closing braces. Okay?
Yeah.
Otherwise, so if you're reading else, read it as otherwise. So just think of it this way. Think of yourself as, let's say you are a bouncer at the entrance of a program, and you are under strict orders to make sure that only people who are 18 years old will enter. So it means if somebody is below 18, no. If somebody is above 18, no. Let's say some 18 empowerment movement, something. So your work is to check, is your age 18? So you take the person's birth certificate and you check. If the person is not exactly 18, then you do what is in the else block. So this means grandparent and parent and young people all fall into the else block. It's only people who are exactly 18 years old who face whatever is defined in here. Now, one difference between Python and most other programming languages out there is Python doesn't use this curly braces for delimiting blocks. Instead, it uses indentation. And the indentation starts with bringing your colon. When you bring the colon, if you have any modern sensible text editor, it will detect that you are writing Python code by the .py extension, and it will help you with the indentation. But don't always rely on that because they can also mess up. Depending on how you write your code, you can confuse your text editor to mess things up. So it pays for you to know how to indent things. Now, the indentation starts with the colon, and then you leave a tab. I mean, I have said you leave 4 spaces or you leave a tab. Now, the question is, which one is better? Because in the Python community, it's a fight. There are people who want to use 4 spaces. There are people who want to use a tab. Now, Edward, think of it. Which one will you prefer, a tab or 4 spaces, and why?
It's easier to click a button.
It's easier to click a button, which is just the tab, right?
Yeah.
Okay. So, I mean, when it comes to typing them, every text editor will make sure that you can use just one. You type one button and it can either insert four spaces or a tab. But we are talking the what we want to optimize for here is the space taken by your code. Let's do an example. I'm going to open a terminal. And then I'll go to my desktop. Let me go to my desktop. And I'm going to create 2 files. So I'll call this tabs.txt, okay? And I'll create one, spaces.txt. Now, I'm going to open tabs.txt. So I've opened this text file, tabs.txt. It's over here. Ignore the other code you are seeing here. I've opened this tabs.txt. What I'm going to do is I'm just going to press the tab key on my keyboard and I'll save the file, okay?
Okay.
So I press tab and I save the file. So this file to the eye looks like empty, but to the computer it's not empty because the tab is an unprintable character. You don't see it, but it is also stored.
Yeah.
Yes. So now we have only one tab in here. All right. Now let's open spaces.txt. So I'm going to open spaces.txt. And one tab is equivalent to 4 spaces. So I'm going to hit the space bar 4 times. So 1, 2, 3, 4. Okay. And I'm going to save this file. Now let's come to my desktop. So I'm coming to my desktop. Oh, one person is waiting. So I'm coming to my desktop, and then I'll look for these 2 files that we created. I'll look for these 2 files that we created. So if I look at the spaces file, you can see that it is taking 4 bytes, okay? If I look at the tabs, it is also taking 4 bytes. Okay. The reason is that these files are so small as at now. But if we keep on including more spaces in the spaces file and more tabs in the tabs file, you'll see that the tabs file will take smaller size on the disk than the spaces. Okay. So I'm going to, do more. And so like I told you, the space and the tab, they are both unprintable characters. They are characters that you don't see, but they have to be stored some way, somehow. Okay, and depending on how you store them. So look at it. You see that now the spaces is 36 byte, and the tabs is what? 16 byte.
Wow.
You get it? So
Right.
for each space you hit on the keyboard, the computer needs to take some memory to store it. It's a character. We'll talk about character sets and all that. So the computer needs to store the fact that you have pressed a space, and a space is represented by something depending on the character sets. We have different character sets, like you can read about ASCII and Unicode. So if you read about ASCII and Unicode, just Google that and read any post that makes sense to you. What these character encodings are is they help standardize how different computer manufacturers represent the characters we use on the keyboard. Otherwise, it will be impossible for you to use an Apple keyboard on a Windows, and even if you have two Windows machines, it will be impossible for you to use, let's say, a Dell keyboard on an HP computer. So there are standard communities that had to come together to agree that we represent the character A with this, we represent the character B with this, so that we can interchange keyboards and mice and all those kind of stuff. Do you get the importance of the difference between the space and the tabs here?
Yes, sir.
Okay, all right, great. So in the Python community, there is a debate as to whether we should go for tabs or we should go for 4 spaces. And now with what information, the information I have given you, you are empowered to make your own judgment. Of course, if you go into a team and it is the team's convention to use spaces, then you have to adhere to that. It's part of being a team player. Because, I mean, we work in different software development companies, and different companies have different coding styles. And once you begin to work for a software company, you need to place their preferences over yours. I'm telling you the truth, you will never work for a company where you feel 100% satisfied, because you have your personal preference, and the company also has their own way of doing things.